Okay, welcome to the resource breakout on Science for Everybody. Let's just jump right in. It's Kevin Reardon is first. Is he virtual?
Yes.
Yes, fantastic.
Yes. Hello.
We can hear you.
You can hear me. Great. So yes, hi. My name is Kevin Reardon. I'm a scientist at the National Solar Observatory. We have our headquarters in Boulder, Colorado, and a telescope in Maui that I'll discuss. So I just wanted to, talk about the science at eclipses, with eclipses, and eclipses, the ways we connect science with the eclipses, and in particular, how I think a lot of people, the public responds to that, right? My experience has been that people love seeing eclipses, but then the idea that there's still mysteries out there, that scientists are also chasing these things and also using these, rare opportunities to try to, learn things, about the details of the corona is also, makes it even more compelling, right? That it's not some solved problem they're looking at, but there's layers of mysteries in what they're seeing. Finding ways to present that to people, to explain, what we're doing and how eclipses are useful and unique is, I think is, an important component, of outreach that would be good to, layer on top of all the other aspects. So you see my next slide there?
Yes, sir.
Yes.
Yes, sir. Great. So, as far as science goes, eclipses, still offer unique opportunities. We have telescopes and spacecraft and all kinds of things, but there's still, things that we can only do in those brief moments of totality, or when, the moon is in front of the sun. And, some of those advantages I have listed there. The scattered light is much lower by having the moon occulting the sun outside the atmosphere. The scattered light is much lower than anything we can, achieve with telescopes or coronagraphs on Earth or from space, for that matter. So we have, that opportunity. We can see, the entire inner corona. We can see farther down. Most coronagraphs don't let us see all the way down to the base of the corona. And we can do things with, time cadence and measuring things quickly, somewhat by necessity. And, the tool that is most useful now at eclipses, nowadays, a lot of the science that we do at eclipses is related to spectroscopy of one form or another, and trying to, break the sun down into its, and looking at different wavelengths and understanding that. That bottom plot there is a spectrum of it's the flash spectrum, that we see right at the start or at the end of totality. That's less scientifically interesting. It's very nice because of all the colors and so on. But looking at the corona with similar techniques allows us to measure things like temperatures, densities. We can look at waves and magnetic field structures and so on. And I just, wanted to mention a couple types of, call it spectroscopy, an extra X there. We can do filters and measure in different wavelengths with very narrow band filters and get temperatures and densities like that. We can put a spectrograph slit. So a classical sort of spectrograph, and measure all those different lines, sort of like the flash spectrum, but that allows us to measure velocities and things like that. So yeah, these are, I'm just some of the techniques we use. And then the other part of eclipses now that's becoming, I think, even more important is when we do things outside of eclipses together with the eclipse. We try to combine a variety of observations. The big one now that we're working on is the Daniel K. Inouye Solar Telescope, which is a new solar telescope, 4-meter diameter, but it was designed and can actually measure the corona outside of eclipses. It's a coronagraph as well. And the important thing is it can give us sort of the actual measurements of the magnetic field during during the eclipse itself. And there's also, there's also observatories that are not in the path of totality that take measurements, during that can either be complementary or the partial phases are interesting. I won't talk about, Kate, Amir will talk about that, but all these, there's different observations that can be done from a variety of resources. And those last two I listed are new ones, that are now we're folding into our current sort of eclipse science, Solar Orbiter and Parker Solar Probe. And they are at the coming 2024 eclipse, they will be in what we call in quadrature. And what that means is that they will be, while we're looking at the sun, so the Earth is there at the left side and we're looking down, we have the Earth, Moon, and Sun in a line, but these two spacecraft are off sort of in the plane of the sky looking down on the corona from a 90-degree angle with respect to what we see from Earth. And so we get these two stereoscopic views of the corona at the same time, which allows us to do a lot of things we've never been able to do before, right? Look at these loops and the magnetic fields and so on from different perspectives at the same time. And the last thing I wanted to mention is some of the science there's some interesting science being done now that's not just about the corona, but actually about the Earth's atmosphere. And we found that the people have looked at the changes in the ionosphere, especially as the shadow races across, the globe, and you can see the effect of this very dramatic cooling of the atmosphere, right? Where you block the sun out for a few minutes, the atmosphere cools down, and it actually, creates this disturbance in the atmosphere that you can see in those time series of maps running across the US from the 2017 eclipse, that you can actually see this propagating across the continent, up in the ionosphere, the upper atmosphere, and you can actually learn things about how the ionosphere works and how it's connected and the waves in the Earth's atmosphere as well. So there's some interesting science, even much closer than the corona. So yeah, that was, just a quick run through of some of the science and why I think it's, can be interesting and valuable to get that out to people as well. So thank you very much.
Thank you so much, Kevin. Probably we are up next. Right, is it me? Yeah, you just leave the microphone right there.
Hello, everybody. This has been such a pleasure to be here and to meet you and have so many different conversations. So I really enjoyed getting to know this community. So while they're putting my slides up, my name is Holli Kohl. I'm a contractor at NASA Goddard Space Flight Center, which is just outside of Washington, D.C. in Maryland. But I telecommute from Albuquerque, so I'm here and will be here in 2023.
Sorry, I'm doing a sec.
No worries, no worries.
Eclipse mega movie?
No, the other one, Holli Kohl.
Oh, yeah, I see it.
There you
right,
go.
right, okay. Find it on the screen here.
So unlike
share the-
the other NASA folks here, I work in the Earth Science Division. And the project that I'm going to be sharing here with you today is looking at the eclipse from a little bit different perspective.
I'm gonna stop sharing and then share. Stop sharing. There it is.
Yep, that's it. So I wanted to, to paint a picture here for you. You wake up on the morning of the eclipse and you go outside and wait a second, previous screen. I mean, that's pretty much the same idea, but is that me?
I'm trying to find you to show. Are you using the clicker?
I'm trying. I didn't hit anything, it just.
No, it's not you.
Okay.
There's something with this computer where this one will take control, but Dr. Speck literally just did this and then fixed it, so I don't know what she did.
All right, so you wake up the morning of the eclipse and you go outside and your sky is completely clouded over. what do? You have an event planned, or you show up at your event, or you're planning an event, and you know that there are members of your community who are unable to directly view the eclipse. Perhaps they have low to no vision. Perhaps there are cultural reasons that they don't want to watch the eclipse directly, or maybe, you don't have enough solar viewing glasses. Are there other ways for people to experience that eclipse? And the project I want to share with you here today is a project that would allow people in these scenarios to interact with the eclipse, and it gives you another activity to do. You're sitting around waiting for totality or angularity to come. Yeah, we can go advanced like 3 slides.
Oh, I know what happened. Okay, the receiver button has disappeared. Somebody unplugged it into.
Oh, well then I won't, I'll just ask you
So
guys.
just ask those
questions.
where are
Okay.
you now?
This activity also works if you're not in the path. If you're off that main path, this is something anyone, anywhere in the whole country can do. Go ahead and go to the next slide. The project I'm sharing with you here today is Globe Observer Eclipse. The Globe program is an international science and education program that engages students and volunteers in 127 countries in collecting environmental data to support Earth-system science. Sorry, that was me. And we have a protocol or an activity that we ask people to collect environmental data during the eclipse. So our URL is observer.globe.gov/eclipse, and all the resources I shared today will. Go to the next slide.
The clicker might work.
Sorry.
Wait, try it now. It might work now because we finally have the receiver.
Okay, well, I'll click it when I'm ready to go on to the next one.
Okay.
So what we're asking people to do is to observe changes in air temperature and clouds during the eclipse, and then record those changes inside an app that works offline called Globe Observer. If you have, the app is free, it's available on Google Play or the App Store. If you happen to download it today, that Eclipse module is not active at the moment, but it will be before the eclipse. We're just checking it for accessibility, making sure everything is good to go. Yeah, I don't think it's working.
Okay. That's all we can hear. All right,
Unless-
Are you pressing the button with the bump on it?
I
Because
am.
That's all right. I'm gonna pull this.
I can even see it. on my computer.
would you put the mic on your laptop? If it's possible.
I can do that. Okay,
Somebody asked for her to put the mic there.
all right. Is that okay?
I don't know. I'm not on Zoom.
All right, you folks, let us know if that's not okay. You can go ahead and go to the next slide.
It's not responding. I'm gonna stop sharing and reshare.
Yeah, that was fun. Will you there? So you guys have heard about the Eclipse ballooning project, for sending balloons into the atmosphere to, measure conditions and watch changes aloft. This is kind of similar, but on the ground. Thermometer, air temperature thermometer. And the app, it's super simple. We do have the app available will be in Spanish and English. The app itself works offline, so I know when you get in a crowded situation, you can't always connect to your cellular network. The app is designed to work offline. It will need to have downloaded it ahead of time, of course, but it will work offline. So let me just talk about the process. Slides will be available via PDF later. So
Ask, I don't think that they are sharing.
But I have absolutely no.
all right.
No, we're on Zoom and it's working, but we lost the Zoom.
And even though we experience that diurnal cycle every day, we're used to the sun going down and it getting a little cooler, particularly if you live in a dry place like New Mexico. There's something about an eclipse that makes that connection so powerful. And it's a great way to help bring the eclipse back to earth, so to speak, and connect to that in a different way, and more, an emotional way. In a way that they're feeling it, they might be reaching for a jacket or something. So it's a different way to engage.
We ask people to take these air temperature measurements every 10 minutes, leading up to the eclipse, and then about 30 minutes before the eclipse, we ask them to start taking them at 5-minute intervals. And then when totality annularity hits, we don't, we stop asking. So there's an alert in the app that asks, is timed out to say it's time for your next observation. Every 30 to 15 minutes, we ask people to photograph the sky, or if they see anything changing, to show us what's changing in the atmosphere, because there are changes in cloud over in some conditions. So it'll be interesting to see, if that happens in April. So we did this in August. You go to the next if it's still working. Ooh. We did this in August of 2017. We were able to get temperatures and the data we had, you could actually very clearly see the path of the eclipse. And you can see the temperature changing. The changes in temperature vary. Some places got a really dramatic shift. You can see that bell curve where it came back up. And some of them were a little bit shallower changes, but it's still very fascinating. And we're able to do some interesting science with that that was later published. All the data goes into a database, the Globe database, that is free and publicly accessible. We encourage students to do research with it, and we have seen a number of student projects based on the eclipse data from 2017. So we're hoping to replicate that with maybe some more interesting data in 2023 and 24. We have annular versus total, we have fall, spring, and we have summer before. So I think there'll be some really interesting comparisons that we can make. I think there's anything else in my presentation I need to cover. Spanish, English, you can make it accessible because you're feeling it. You can get accessible thermometers that speak the temperature. So somebody with low vision can participate in the citizen science experience. We do have a number of resources. We have some associated educational activities to help you learn how to make the observations, activities you can do with a group. So I'm going to be at the Blue Fiesta, and I plan on doing an activity where we're teaching people how to tell about different types of clouds and how those might change in eclipse conditions. To prepare ahead of time, I would recommend exploring the website, download the app. You'll need to register with an active email address, but that's it. There is some in-app training for the protocols that should step you through everything. And then I guess the last thing I would add is the contact, I need help, contact me button in the app and on the website goes directly to me. So if you have any questions or you want to chat, I can actually send you my card that you go home and start playing on games and have fun. Don't hesitate to. It feels like you're just filling out a form and no, it's coming to my inbox, and I'm happy to hear from you. So I will leave it there since I guess we will apply to no. I will take anyone. Now the app that I'm glad you asked, because we're collecting your email address so that we can communicate illustration, and we're getting a location when you're taking data to me. We are very, very careful to keep we never show your email address anywhere. But those two things together are personally identifiable information for minors. And so children under the age of 13 really should be using it with an adult for that reason, just because they're being super, super cautious about contamination. You can have multiple people. Yeah. Yeah.
When you have the app to download it, is it just the Globe Observer
Correct.
app? Okay.
Globe Observer.
Okay,
Yeah.
perfect.
And it's free on Google Play and the App Store. The logo is the one you saw on that opening screen,
Okay.
or I can give you my card.
I found it useful in education. Made a difference in the cooling rate and really educational because of course what happens every night. So another atmospheric project you might think is color changes are that sort of eerie feeling you get halfway into the eclipse. They photographed a white card all the way through the eclipse and then ran the edge RGB proportions of it. You get some idea of whether or not there was a color change during the eclipse. So atmospheric project.
That's a great idea. Phones do, like the generation of phones do have weird filters on them, so they could photography might.
Everybody else needs to ask a question.
The question from the audience was heard just fine. She can't be though.
Weird.
Yeah, I'm wondering, somebody thinks that the microphone that you're using is not actually the microphone that's being used for Zoom right now. Which is entirely
Crazy. Okay, is that better?
Yeah, we need to move on.
Okay, let's just move on. Happy to chat later. Thank you.
Do you have a conclusion on what's being typed to Zoom? Here is next.
Amir already gave us presentation,
Fabulous.
so we're just he's gonna be here for the Q&A.
Love it. Juan Carlos Martinez Oliveros. Online. Not online.
Right here.
I thought it was virtual, but no, here you are. Okay. Let's see if we can get the microphones.
Wait, actually, somebody just said that Rick was the clearest one just now. So weren't you just using a handheld microphone?
I was.
Maybe we should switch back over to the handheld microphones.
Okay, we'll do that.
And I'll mute that one. Okay, testing. That's it.
Testing. Everybody can listen to me?
We hear you.
Thank you.
You're good.
Okay, so my name is Juan Carlos Martinez. I'm a researcher at the Space Sciences Laboratory at UC Berkeley. And I'm going to talk about the Eclipse Memory Command Mega movie, the version 2.024. So my name is not on this slide because I don't deserve the credit of this thing that I'm going to show. It is mostly the credit of the old people that work and share all the images for us in the last decades. So as Amir already explained, why we want something like the mega movie, because if you want to see a dynamic process, then you need to see it with a good cadence. If you want to see, in this case, the elephant moving, then you need to picture or several pictures just showing how it's moving. In the case of the sun, next slide, what we want to observe is transient phenomena. That's our main objective, is to observe these transient phenomena and their evolution in the solar corona. And we also want to the registration of the eclipse with high cadence, so we can see all these different changes in the corona with high precision, like 10 cadence. And an extra bonus that we want to see is the baby B, because some people, like Watson, is very interested in measuring the solar radius with high precision. Okay? So this is the type of observations that we want to do. This is also popular. And then you see this transient phenomenon. Next. And there here you have two images from the last Eclipse megamovie experiment given by this observer. And you can see the quality of the images that we're getting from the people. And we should say that the important thing of the megamovie is that we do not ask people to be a professional. These are images from normal human beings on the ground with their cameras pointing at the sun without equipment. So we did all the effort to do the best that we could to reproduce this. This is another one from this person, but it's an awesome image. So when I say volunteers and person on the ground, it doesn't mean solar physicists. We have astronomers, astrophysicists, amateurs. We have a whole bunch of different people in this community that provided all the images for the mega movie in 2017. Yeah. Here are some faces. I cannot put in here the 12,000 that we have. So these are just some faces, and you can see the different equipment that they have. So we have telescope, cameras. Some of them have weird things in there. I don't know what is that. Really honestly. Next. So to take a look at how well we did experiment, we need to measure it because we could see it in any way. In image, and we think we did. The idea was the engagement of the public in the generation of these catalogs. But we did it We have 12,000 volunteers. About that, we have a free app. that People could take pictures, although these volunteers that not include the app users. And we have about 1 terabyte of images in the public domain. So everybody can download it and try to do something with it. This is how all the different images were produced at different locations. And you can see most of the challenges came in Nebraska. There's not many people in Nebraska, I guess. I'm not a US citizen, I don't know. But it looks kind of blank here. Next.
That's what I was thinking.
Oh, next one is product erasure. So how we did this, we took the images from the volunteers, we created a database, and we used regulars for application. So all of them were in different directions. Well, of course, first we filtered because there were some interesting images, but not pages 16, pages 13. Really interesting.
No.
Oh, yeah. But they send it to the server to filter out all the adult content. So for this, we created a new image repository with the rotated images, and we co-aligned and started to correcting by awakeness because all the images were done with normal cameras. And not perfect. The new co-aligned data, then we start to using HDR algorithms, Gaussian algorithms to try to see the corona. And that's the new database that people can. These are the kind of results that we get for one server. So the thing is working, sort of, it's working. You can see clearly reckless in it, you can see the moon, but you see all these kind of contours that you have in there. That's mostly related to the lens, and the quality of the lens. And I will talk a little bit about what are the challenges for the 2024. So what we learned is that the instrument ecosystem is too complicated. There's far too many different things. One of them, of course, is that although we try people to tell them that we need things like flat fields and dark frames and all those things to make this an astronomical kind of observation, they did. They were so excited that they forgot, which is fine. Then we also had another problem that is the bracketing required to do the HDR was not standardized. And the reason for that is that the lenses were different things. Small ones and big ones. We had a lack of a core number of collaborators. Did not have that because we will not impose it anybody in any way instrumentation that is required. And I just said the training of the volunteers, that's most of the work that was done for the mega movie. There's serious problems with the training following the fact that we didn't get the important information of the flat field. It happens one of our collaborators with his different instrumentation, and that's just to show you the difference between different instrumentation that we have. Professional cameras with cell phone. Next. So what we are trying to do is measuring dynamical changes in the corona. So we are trying, at least we are trying at this moment, to reproduce one paper that comes from the Japanese scientist, Hara. This is a paper from 2018, where they see these flows in the solar corona. So these are the input images that we're using. This is being done by an undergraduate student. It's very common. And if you do the differentiating, then you see all the crap that is in that. This is the kind of quality of image that you get from Hanaoka, the one on the left, and the one on the right is the one that we are getting. Clearly, there are serious challenges just to get the correct information for this type of analysis. Okay. So for the 2024, we are going to have several changes. One of them is how the public is going to be prepared. We are going to ask them to have more consistent communication. That is easier for us to prep all the data afterward. Of course, we cannot tell them use this telescope or use this camera because this is a public. Cannot do that. But the principle is that data that we want to collect should be easy to be run. It must be easy. Next. And I just finished with the phases of more volunteers. We have all of them explaining things in YouTube, and how to make a mask. For example, those things from the Google forums that we have. So this is really the good thing about it. Thank you.
Seems like we've figured out how to pipe in and to this external system with this